Okay, seems you're live. Um, Good morning, good afternoon, good evening, depending on which part of the world you're watching us from. We are super glad to see you again on this Saturday. I'm Mudit from AI Planet. We've been known as DPhi so far, so if you've been a part of a community for a long period, I think this will be a change that you might notice for the first time, maybe. So we changed our name to AI Planet with a similar vision and a bigger ambition. Now, AI Planet, for those of you who do not know, is a global AI community. Our vision is to educate and build artificial intelligence for all. We started back in around 2 years ago, and right now we represent a community of over 100,000 plus AI enthusiasts from 150 plus countries. On our platform, you can access resources which are created by leaders and change makers like Supreet and Thom, who are with us today, and you can access them for free of cost. So that's a brief about AI Planet. And with me, I have Supreet, whom a lot of people might know by now. She is our co-host and a long partner. So Supreet, why don't you talk about yourself, Databuzz, and the topic as well?
Yeah, thanks, Mudit. Hi, everyone. I'm Supreet. My day job is that I'm an AVP at Morgan Stanley. But on the side, I love to give back, and hence I started my own community called Databuzz a few months back. And we are a completely volunteer driven community. And our goal is to help people who want to pivot in the field of technology, data science, AI. And we do that by sharing some useful resources, organizing these AI talks, organizing fireside chat series, and you have access to all of them again, free of cost, through YouTube or through our LinkedIn page. So I think today we again have a very special guest. I don't think he needs an introduction. He's a LinkedIn star, as we all know, Thom. And we had a session with him, I think now maybe a month or so back on this topic about UI models and deploying it using Streamlit, and it was a hit. So we decided to do a part two of that, and Thom is there with us. So, Mudit, do you have any other words to introduce him?
Oops, I was muted. So yeah, I'm saying that let's just loop in Thom and dive right into the session.
Sure, sure.
So, yep. Hi, Thom.
Hey
Thank you.
everybody. Hi.
Hey.
It's great to be back. Love your crew.
I
Yeah.
think the community is equally excited to have you back, Thom. So, without any further ado, we will hand over the entire stage to you. We can dive into the session, and we can also probably discuss about your interesting hoodie that you're wearing today. But yes,
Oh yes.
yeah, cool. So maybe we'll go to the backstage, and it's over to you, Thom.
Very good. Thank you. Um, yes, I hope it's not any surprise to anyone that Robert and I are buddies. So let me get the right screen here. Now, if you were at the first session, we were talking about REST APIs. And REST is a certain type of API that was created by a very um, uh, good philosopher of digital arts and such. And I'm going to just clean up as we go here a little bit. But I got into REST APIs a while back, first just using them. And then I decided I wanted to create them. And I presented about those last time. And I think for the data scientist that's in a team where they don't have a dedicated team to deliver your models, the tools are getting so good now to where it doesn't take a lot of extra effort to learn to create your own REST APIs in pure Python now, in fact. And thanks to the Streamlit team, it takes even less work to deliver a web UI based uh, model delivery service. And so last time I was with you, as I was saying, showed you how to do REST APIs and using FastAPI, which is an incredibly clean and good module for Python to develop and deliver REST APIs. It's very good. But again, with REST APIs, we're really just making a URL method call, an HTTP method call, and we went through a case of that, and I'll be sure to share with your community a more complete example for doing an API than the one that I showed. At first, I naively thought I could present both the REST API section and the web UI, and I reached out to Supreet and I said, oh, can we please do 2 sessions? This is, as I started to develop the materials and realize all the steps that I wanted to show, I thought it would take 2 sessions, and they graciously allowed me to do 2. So they're going to let me know as we go through if this is not large enough font-wise, and you guys be please do not be shy about letting them know you still need it bigger or not. But the Streamlit team, they're amazing, and they're creating Streamlit open source. So if you wanted to leverage from that and make your own stuff, you could. But they're doing a great job, and I've actually talked to some, and I can already tell we need it bigger here. I've already talked to some full-time data scientists that do consulting work, and I asked them, hey, when you deliver your tools using Streamlit, do your clients ever complain about the look and feel of Streamlit? And one of them said to me, not yet, but we have this really big client we're about to deliver an app to, and we'll get back to you and let you know. And they actually did get back to me and said, hey, they loved it. They didn't say anything about the look and feel. So Streamlit has been very careful, since it's a very high level tool. It's not like working with directly with HTML and CSS and JavaScript. They deliver what they deliver, but the benefit is that you deliver a very short code to develop your web user interface for some analytical tool very fast. So I've already created a repo, but once it's actually put up on DAG's Hub, which by the way, I like GitHub, I like GitLab. Why do I use DAG's Hub? I use DAG's Hub because they're focused on data science and machine learning, and they've grown fast, and they're adding improved services all the time. So that's a plug for them. They didn't pay me to do that. And also, you'll notice I'm wearing my Robert Show hoodie. I do this a lot because I think Robert is the super glue of our community, much like AI Planet, formerly DPhi. So all good groups to belong to, and mine too, if y'all don't mind me saying, Integrated Machine Learning and AI. Connect with me on LinkedIn or ask me in a comment in one of my posts, and we'll get you added to our Slack group. So when I deliver this, you'll have access to this notebook, which will also be in PDF and HTML format, just like the other one. And by the way, if you haven't found that one, when I share the new link for this one, I'll share the link for the old one too, so you can get to all of them. Okay, now I just say a lot of cool things about Streamlit, which I've already said in this text, but basically I was struggling with another method to deliver web user interfaces, and I was thinking I would do that with FastAPI, but the approach I was using, I realized, was not a very smart, sustainable approach. But in my efforts to make it better, I finally came across Streamlit, and I kid you not. Now, I'm a fast learner because of my age and my years in this industry, but it literally only took me about 2 hours of easy study. And then the thing that I've been struggling with for weeks, literally after that 2 hours of study, took me 30 minutes to write my first app, much like the one I'm going to show you, and maybe another 2 hours just to refine it and make it look better. So it really is a speedy tool. And you can start out literally this simple: pip install Streamlit. You could put that in a current virtual environment. And let me give another plug here. Python is always getting better. And if you haven't learned how to use virtual environments yet, I encourage you to do it. Now, a lot of you may be using Anaconda. I'm not an anti-Anaconda person. I just want to encourage you, eventually you want to learn to start a new virtual environment from scratch and add only the modules you need, because when you go to Docker, which I'm going to show you how to add this into Docker today, you want that Docker image to be as small as possible. And so you don't want to be adding the whole Anaconda environment to a Docker image or container. So as we create a virtual environment for a Streamlit app, we're going to need Streamlit. And in case you didn't know, if you're working in a notebook and you don't want to necessarily go to the terminal like I'm showing here, you would just put a exclamation mark, or a lot of Linux people call this a bang, an exclamation mark right in front of this, and then you can treat it like a command line. I think that's seriously helpful. All right, so we're going to do a code overview of the code that will be run from our web app. And when you get this repo, there's just 3 basic files I'm working from. There's A, basic fake data model train and store. There's B, basic fake data model test and measure, and web app code. Now, if you were at my last session for the REST APIs, you'll think, oh, are those the same 2 names? They're exactly the same 2 names doing exactly the same thing. The only thing that would change is the random fake data we're going to create. Now, another thing, a plug for fake data. Why fake data? Well, it's easy to create, and once you learn how to create good fake data, the data science world is your oyster. The machine learning world is your oyster. Why? Because once you understand the realms of the data that you're really going to use, your real world data, you can replicate it in even harder ways, or excuse me, ways that are harder for your application. And that's a benefit, because you don't have to wait on data or to get a certain type of real world data to test the boundaries and abilities of your application. So I've always, that's one of the things I post about a lot, is how to create good fake data. And I want to give credit where it's due. A guru that I like to go to for help is called, and please write this down, The Lazy Programmer. He's on Udemy and he has his own website, and I love the way the guy teaches. Now, it's a bit more hardcore, like when you see my code from scratch posts, like don't use the libraries, let's do this from scratch so we can practice really putting the algorithms into code ourselves without always using scikit-learn, which I love. That's for conceptual understanding. Well, he's that way too, but I get a lot of my admonition to use fake data from his good practices there. Now, for this model, we're going to use our beloved NumPy and Pandas, and we're going to use Pickle. And if you've not used Pickle before, it's a really good storage module, and it's quite flexible. And by the way, it's actually integrated into scikit-learn now. So they're big proponents of using Pickle to save trained models, for example, and we're going to use it that way. By the way, in case I'm talking too fast or introducing new things too quickly, I assure you, everything's recorded in here. I prefer y'all not to take notes so you can listen better, because again, I'm going to be sharing all of this stuff in a repository on DAG's Hub. Okay, now to actually create the features, X1, X2, X3, we're just going to do this random NumPy random uniform distribution. We're creating features that have equal numerical magnitudes. Why? Because in a good machine learning development process in the pipeline, we would have already cleaned our data, conditioned it by scaling, reduced the number of features to only the number of features we needed, engineered the features, and finally done the modeling work. So we're jumping way ahead and saying we have scaled data and we've got 1,000 points each, and we're spoiling ourselves with the fake data. And we're going to horizontally stack those together with the NumPy HStack module. Now we're going to create our fake labels. And here's the beauty of fake data. We already know what the coefficients of the model should be when we train it, but we're being fake data prophets. This is another advantage. If we go through and we've set everything up before we get our real world data, and we do our training and we don't get close to these coefficients, hey, something's wrong. But we're going to make it more realistic by adding some noise. So I'm just taking the max value of all these y's, multiplying it by 7% basically, and making that a peak noise. And then I'm going to have a noise profile that's normally distributed. And I'm going to also create 1,000 points of those. And I'm just going to add it to my fake label data so that it's more realistic. And I would encourage you guys to add some matplotlib.plot, some PLT statements in here, and look at a plot of the features versus this label. Look at, make sure that, yeah, that is normally distributed noise, etc. Okay, next. Because we're doing a machine learning problem, I'm going to go ahead and train test split this. I use a random state, so it's always the same split. And by the way, I probably should have done this random state higher up so that all of these data points would always be the same. But as one of my favorite cooking channels on YouTube says, you do you. I don't mind it being a little different each time. And so you can see that I've got a training set. And so for the features, we've got 800 of those records of those with 3 columns and 800 labels. And then we've reserved 200 features and labels, or feature groups and labels for the test set. Now we cheat. I always feel like it's cheating. And I don't mind, by the way. We just are going to, now let me show up higher. We imported that somewhere, and I just want to show you where, right here. We imported linear regression from the scikit-learn linear model module. And from there, we're now creating an instance of that class. I'm keeping it simple here. I know I don't need an intercept to fit, but normally I would have this set to true. I just am keeping it clean, and I'm going to copy my X values or my features, and I'm going to do a model fit. And then what I did here is I just made sure the training score was reasonable for the amount of noise I had added. So I'm looking at the score, and I'm also looking at my coefficients. Now, why would I go ahead and look at those? Well, I always look at them, but I wanted to make sure that even with that added noise, it was getting close to my original defined coefficients, and it is, because we picked 1, 2, and 3. So we're good. Now, here's where we start to pretend, well, less pretending. Let's say we trained that on real world data, our latest data for some production process. Now I'm going to define a model file name that I'm going to save this to. So it's linear regression model.pkl. And if you're not in the habit of using Python context managers, I'm begging you as your friend and big brother, start doing it. It cleans up your code. This does so much for you. And in fact, I got so excited about context managers when they came out. I went and learned how to make my own for those cases where there is a Python module that doesn't work with context managers, but a lot of them do. Even your PyODBC calls, by the way, when you're working with SQL through Python, I use context managers a ton for that stuff. So with open. We're opening that file name, and we're going to write out as a binary file because it's a huge scikit-learn model file as F. We're going to dump that trained model that's already been fit to this file name that we created because we said as F. And then I'm going to do something else just to keep it stored. I'm going to create a data file name. This is a NumPy Z file, which is great for storing NumPy data or NumPy data structures. And so with open data file name, etc., I'm going to save that to that file name. And what am I going to save? The data structure is a horizontal stack of the X test and Y test data. So what this is, it's my pretending that we're getting new data in. And this is the data we're going to test with. Okay. Now I'm going to create a test data frame, pandas data frame, the X test data, and I tell it what the column names are. And then I'm doing that as a convenience because I love pandas. And I'm going to write that data frame to a CSV file and use that as my xtestdata.csv, a comma separated value file. Okay, so the outputs from this first script are shown below. We already saw the outputs of this in the cell, but this is me now running it from, where'd it go? This is in, okay, here's I'm deep in my own directory structure here in this example. And I'm running Python from this virtual environment here in this case, which is a big one. I needed a cleaner one. And finally, here's me running that file, a basic fake data model train, which will be in the repository. So there's the test and train shapes for the data and the score and the initial coefficients I got when I first ran this and did a screen capture of it. Okay, now test the loading of the saved model and data and test the model. So we're going to do all that together. So now I'm going to the second file, basic fake data model test and measure. Now, unfortunately, we have to go through all this because we want to understand what we're putting in our Streamlit model. We haven't gotten to Streamlit, and I'm trying to get there quickly for us. Okay, so we still need to import this stuff. And the reason I'm importing math, when I took some training in data science from Microsoft, there's this wonderful professor out of Washington, and he shared this function, and I've been copying it and using it ever since because I thought it was brilliant. And so if you ever want, you can break this apart and go look at it. But I just thought, wow, what a handy function. And I've cleaned it up and used it. Like, I think I cleaned up these print statements, but I could still do some improvement there with some F formats on this. I just have used it that long. So that's just defining that function so that we can look at metrics of errors and model accuracy using R squared. Now, we're going to just load that model from the file. We're going to pretend that, hey, it was stored, and now we're in a production script, and we're loading that model up. So model LR from the pickle load. So the pickle, we used the pickle save or dump, and now we're using the load. And we're also bringing back, we could have done it with the CSV file too, but I'm just saying I want to open the feature label data. So I'm going to do the NumPy load of the NumPy save that we used before. We're just bringing that data back so we have it. Now, there's other ways to do it. Why did I do it with the NumPy file? Is so I could also get to the Y test values, so we could see how good our trained model is doing on our test data, like our pretend new real world data. All right. And then I break that feature label data into all the X columns, all the feature columns, and then the last one, which is the Y label. Now, if this looks strange to you, there's a way to make it not strange. You want to understand how to take NumPy arrays and slice them. Because this was a two-dimensional array, this means all rows and all but the last column. And this means all rows and only the last column. So if you join Integrated and you can't find help for this in any of the many brilliant NumPy tutorials out there, I'm certainly glad to help you. Even though I knew NumPy pretty well before I discovered these tricks, a nice fellow PhD showed me, oh, Thom, you just need to use this and this. And there's, even for this, there's a way to do start, stop, step size. And this is shorthand for just use all of them. But you can even get very specific about which rows you use in this, etc. But I'll go on. Now, we have model LR or mod_LR loaded. And so we're just going to go on ahead and use the predict method of that class that we brought back. And we're going to pump xtest into it. And that's going to give us some y predictions. And we already loaded y test up here. So now we're going to compare that to y predict with our print metrics function that I showed you above. And you can see that we're getting pretty low error and pretty high accuracy for this model, which had, again, 7% noise. And in real world data, we don't necessarily know the percent noise. We probably could figure it out. It'd be more like a standard deviation value, though, like I used. So it's a pretty hefty amount of noise, actually. And so we can see we're doing good. This is the latest run. This was one I stored before. And I do this in case the notebooks get shared and these output cells go away. But I kept this up and running from last night when I was double checking everything. Okay, so great. We're close in our training accuracy and our test accuracy. We could be more accurate, but we've got noise. So now we look finally at the Streamlit script that would create a web user interface. And this is pretty amazing. Now, again, I invested in 2 Udemy courses, and a note about buying video courses. I frankly never pay more than $20 for those. I wait until I can get one on sale. It seems like there's always an Udemy sale. So when you can get a good free one, snag it, please. And please don't judge me. I really don't own enough Udemy courses. I think maybe I'm approaching 350 of them. Yeah, Udemy. I'm addicted to Udemy. I love it. And even when it's something I already know, I kind of like to see the way others teach it in case I haven't thought to explain something a certain way yet. Okay. Now I convert from talking about Streamlit up here in the notes to talking about it in the code. So this code in code blocks, and by the way, you would not, this is all in this code right here. I just want to point that out. This is where it's all put together, and we'll go through that a little bit more here in a minute. But I'm showing it in cell blocks, so it's just a little easier and a little to view and a little easier to check out when I convert this to PDF and Markdown and HTML. However, what's nice about this is, I did not run these cells, therefore. I would, because again, I'm going to run from a command line. When we start the server that serves this Streamlit app, it's going to serve it up into something that looks like this. And I'm going to show you more of that here in a minute. But we're just talking through the code right now. So we import Streamlit, and I like to use aliases, so I'm not typing that much, but always use an alias that makes sense. Like we do pandas PD, numpy np. Well, for Streamlit, I just chose st. Choose SL if you prefer. It doesn't matter. And then I'm going to st set page config. Now this is important though, and you can choose a wider layout. Sometimes you actually need this depending on how you want to lay out your web user interface. But I just do my page title, which is important because it shows up in your tab. Now here I didn't update the name yet. I've got it. Simple Model Serving Web API. I had changed that recently, but Model Web UI, and then your fave icon, which I chose my integrated machine learning and AI icon, and then but that needs to be right after your Streamlit import, and then you can start importing other things. So we know we're going to need pickle. We're going to need we don't need pandas and NumPy, but I had these in there. I don't have it in the final version. I will update the copy of this when I push it up to the repo. Okay, so here, I'm just, now again, I'm in the Streamlit app, and when the Streamlit app opens, I'm proposing that I go in ahead and load my model file. And I get my model class instance that we had already trained. But I think there's a smarter place to load this in the long term, and we'll talk about that here in a moment. Then I prepare some text values here that I'm going to use in a minute, and an output file name. And then this is where the body of the Streamlit app starts. So again, a context manager, and with a Streamlit container, in this container, set the title. And you can see the result right here. And get predictions from the latest model. So that's what's happening right here. And then, now, because I'm in dark mode, it's harder to see, but then it creates this divider line with this type of markdown. And this is what I just started getting geek chills. That's me saying I'm excited geek. You can use markdown statements in here. How cool is that? So and you can see why this code's not going to run good, because I'm breaking all these context management statements up. But with the ST container, the upload title is a subheader, and upload input data file. Now, please understand, this is helping you appreciate the elegance of Streamlit. I'm not trying to teach y'all Streamlit. I'm trying to give you an example of how elegant this code is to deliver something like this. You could not do this in as little amount of code as I'm showing you if you were to do it from pure HTML, CSS, and JavaScript, and then you'd have to do Python and interact with it that way. Streamlit has really is giving us a lot of handy tools here. So we've done for the input section, we've talked about the input data, and then I've upgraded this to, I say upload a CSV file. So let me show you the new format. Again, sorry I didn't update that code. I forgot to do that. So use CSV file format. And this was the thing that drove me to Streamlit. The amount of things you'd have to do in a Vue.js library, or the confusing way you'd have to do it with FastAPI, trying to push FastAPI into a realm that it wasn't really designed for. This is super elegantly done in Streamlit. And again, even if you were using a modern JavaScript library, there's a bit of a learning curve just to get to this point. And I'm sure you could all do it, but why waste the time when we're data scientists? So then, if there is an input file, in other words, I don't want the run model button or the make predictions button to show up unless there's an input file. And that's another cool thing about Streamlit. I was able to conditionally decide whether the button for make predictions was going to show up by, hey, do I have an input file or not? And where do I say that? Right here. That's only going to populate that variable once I upload a file there. And again here, being able to use a conditional on did I get the file uploaded. If it's not none, then we're just going to write that to a buffer. This is all super easy. So now this is handy for me. And by the way, what am I doing here? I'm putting this file on the server side, and I'm getting the buffer that it, this is a whole class, by the way, when it loads. So get buffer just means get the data. And when you go through a good Streamlit course, and again, it won't be hard. You could even do it. You don't have to buy an Udemy course. There's a lot of good free tutorials right on the Streamlit site, by the way. I should have mentioned that earlier. So once I've got that input file data, I can say make predictions. And so if a, excuse me, if a run has been requested, in other words, that means the make predictions run requested, then it starts giving these updates that I'm talking about here, loading the new data, data loaded, sharing predictions. And again, here I'm reading in that CSV file because it came in as a pandas data frame. And I keep going. So then, or excuse me, I'm sorry, I'm loading it to a data frame for the feature values. And then I'm converting it to a NumPy array right here. That's all that's going on. Data loaded, sharing predictions. So that's another info statement. I'm going to show you how that looks. And then we're going to do this real time, but I'm waiting to show you the real time version until we get to the one running from a Docker container. So I've got the data loaded. I can go ahead and make the prediction with the X test values that we loaded. And then when that's done, I know it won't go to this until those are done, so then I can report predictions complete. Now, that's not showing up in this window yet because I haven't ran it from this one, but we will. So you can see all this real time, what happens. And finally, I need to download the output. So another divider statement with just markdown, a subheader, download the output file, and then the previous download markdown text that I created earlier. By the way, I did that just so that these lines wouldn't be too long. I try to always be PEP 8 compliant, but I try not to be hyper about it too. So that's what that stuff looks like, but we're going to look at it in more detail. And by the way, I have screen captures of all this below. But now I want to show you what we do. So once that code is built, and by the way, I encourage you when you're writing a Streamlit app, this is super cool. You can write it a little bit at a time, start the server the way I'm about to show you how to do, go back to the main app code, add a little bit more, and then Streamlit will ask you, do you want to rerun it? And I'll show you what that looks like here shortly. Okay, so this is how you actually start a Streamlit web app. Just stream from the command line. And here I'm in the same directory that my web app _code.py file is located in. And I do Streamlit run and the name of my Streamlit web app Python code. In other words, at the prompt, this. And of course, if you name it something different, just use the name of your code. Well, this too, I got to tell you, after using other server programs that serve it up, I hate having to go find by IP config. Okay, yeah, that's what it is on localhost, but on my local area network, I can't remember the IP of my machine. Boom, Streamlit reports, oh, to the rest of the network, they can get to your app with this right here. So here's the URL plus the port number. I went, Dang, thank you, Streamlit. Well, once we've ran all that and we've developed, by the way, I developed this a little piece at a time. This is what the initial thing looks like. And again, I wanted to update that title up here, but there's my fave icon, my application title, my big title, my subtitle that I created. And here's the whole web app when you run it. You see, I can't, this is, there should be a way to grade this out until that output file exists. I just didn't do it there and I should have. But notice that the run model, the reason that's there is because if that output file is still there, you could go back and get it again. But the run model, the button to make predictions is not showing up yet because I don't have an input file yet. So why make that available to the user when it would just error? So we can control those things very quickly and easily. Now let's upload our xtestdata.csv file that we loaded. This is our pretend that we got new real world input data that we didn't train on again. Of course, we know we have the output data, but we're pretending we don't. And so once I click on the browse files, I can navigate on my local machine to go get this xtestdata.csv file, and it reports which one you uploaded. Now, when I do that, the Make Predictions button shows up, and after I click it, these are the reports I get as it's running. Now, because this is a small model, these show up almost instantaneously, but in reality, they are going 1, 2, 3. So if you were running a huge model and it was going slower, the user would see the predictions of these info blocks showing up. And Streamlit provides many different types of info blocks. There can be just pure info, there can be an error, there can be a warning. They provide a lot of enough reporting blocks for us with different formatting. Now, when all that happens, you download the download out output button shows up, and then you press that, and you'll see a typical file download dialog box. And I'm going to show you that here in a minute from the Docker version, but you download the file to where you want it and check the contents, and then we sing the Dora Explorer We Did It song. Sorry, I've raised a lot of kids and I have a lot of children's show references. So you can just thank me that I don't use the Barney references as much anymore. So this is a first summary. We use Python Streamlit to create a web app using pure Python. And I've been waiting for this day, frankly, for like, when did I start? I first started studying full stack development stuff because I love it about 6 years ago now. And I thought, well, okay, Flask and Django, they're nice, but why do we have to use so much? I love JavaScript, by the way. I sometimes wonder why the data science community didn't embrace a version of JavaScript that runs, on your PC directly instead of just in a web server. And because JavaScript is so cool, but we didn't get that. We got Python, and Python's great too. But it made me want to be able to do all of that web stuff in Python. And thanks to the brilliance of the Streamlit team, we now have that. So, and that web app provided model predictions using a trained model, just like we did with that B script right here. We did all of that instead inside this web app code that we launched in the Streamlit web serving. And let's see, let's go up here. But that was fun. And we discovered some great new power and methods using Streamlit. And Streamlit can do a ton more cool stuff that I haven't shown you yet. You can use it for dashboards, by the way. It's very good for that, web-based dashboards. So, but I'm not going to go into all that right now because, again, this is an intro I should have said this at the very beginning. I'm trying to help you with me explore more elegant ways to do continuous integration and continuous deployment of machine learning or data science or analytical applications using a web user interface. Now, if we do that from some server and someone goes and updates a library, a module in Python, oh, that just messed up my application because for example, Streamlit is running the latest version of Python it works on is 3.10. And yet, on the server that I help control for my team at Echo, we're using Python 3.11 already. So we also have to have a version of Python 3.10. And then for each of those Python versions, we should have virtual environments for each application. Or we could share one virtual environment for a few applications that use roughly the same Python modules. But then what if someone just decides, oh, we don't need Python 3.9 anymore? And they survey the team, but I'm on leave, and I come back and I find one of my applications isn't working anymore. I don't want any of that to ever happen. I don't want to ever have to worry about that or fight that. So I'm going to use Docker, because Docker is an amazing tool. And if you haven't learned Docker yet, be patient and gentle with yourself. It's a whole new way of thinking. Now, if you love virtual machines for the same reasons I'm talking about, well, Thom, I could run a virtual machine on a server and then serve my web application from that. And I could just keep that running forever. You know, it would always just start up, that virtual machine would start up, and it runs some version of Linux or Windows, and then I could have even just use the system Python there, and it will never change. That's a great point. The only problem with that point is you're using a lot of extra resources that you don't need to use. What if I could give you something like a virtual machine and something like a Python, something like a virtual machine, but it didn't need the whole operating system kernel. But yet it had its own file system, and you could run versions of programs in it and versions of modules for that program, and it would just run that way forever. Well, that's as a virtual machine is to VirtualBox or to VMware, so is a Docker container that's running a Docker image in Docker Engine on a computer. It's very similar, except Docker images and containers are much more lightweight than a virtual machine. And that's why Docker is becoming so popular, because once your server or your computer is running Docker Engine, you could spin up any Docker container, and it's like a very light virtual machine, except it's using the operating system kernel, but still it has its own isolated file system, and that way your application can run without problems forever. Well, in theory. And so now, you may not know Docker yet, and that's okay. Let's just look at how we create a Docker image first. So I'm going to start from a base image of Python 3.8.10. Now, what does this mean? Well, I'm using Docker for Linux right now, and I hate to talk this way, but I really feel this way. There's now Docker for Windows and Docker for Mac. And I got to confess to y'all, I'm a Linux snob. I'm encouraging you all to learn Linux. There's many strong reasons. I could give a whole other presentation on why you should be learning Linux. But I thought, you know what? I don't hate Windows. I just get frustrated with Microsoft sometimes. They make some great products, and then They make things that, why did you do that? It was already better in Linux. Why don't you just learn to serve Linux, Microsoft? Well, I actually tried to do some things with Docker for Windows on Windows Server 2019. And the images were huge, the base images. And my son-in-law, who's brilliant, he's a cloud architect expert. And when I said Docker for Windows, he looked at me puzzled. And I said, you too? He said, why would they do that? In short, please, I went to Echo IT and I said, give me a Linux server so I can get some work done. Because it's not that you can't do good things with Docker for Windows, but it's just, you're going to hit limits, you're going to hit bigger images. And when I explained to my leadership why I wanted this, they said, get out of Thom's way, let him have a Linux server. So, but this is a Linux-based distribution with Python already built, running properly in it at version 3.8.10. And so it's probably Ubuntu server with Python fully installed on it, and I get to start from there. So in a Docker file, you're usually starting from some image like this. Then, and again, this is just a high-level overview to give you an appreciation for how elegant Docker files are, Docker images, and how we can launch those Docker images in a Docker container that serves your app. So all this means is I want you to create a directory under root, under the top level directory structure on this Linux server called source. And when you say work directory, it creates the directory and changes to it. So this is a Docker unique command. Now copy means I'm going to copy from my host system over to that source directory in the image. And then why am I doing this so early on? This is the requirements.txt file for the virtual environment, for the Python, system Python on this, inside this Docker image. I'm going to get all my pip installs down. Now, from that virtual environment, I encourage you to create earlier. And up here, I'm using source now. Oh, I want to delete this real quick. Forgive me. I don't need that. Yes. Okay, we're in this Docker file, but here's that requirements.txt file. And I did some research to get this as lean as possible. This will take care of bringing pickle in for us, by the way. So I just wanted to keep this as lean as possible, but here's a very good thing to do. Since I tested in that virtual environment the minimal amount of installs I needed to do to get this app working, I also, when I did a pip freeze in that virtual environment, it told me these were the versions using. By the way, this just confused me, but I believed it. And that's the one that I'm copying over here. And then I do this pip install, but of course that installs a lot of dependencies. And when you build this Docker image the first time, this takes quite a while. Just pulling this down takes quite a while. But after that, when you redo things, as long as you keep the stuff that takes the longest amount of time up front, then when you make these other changes lower down, the rebuild of the image as you're troubleshooting it goes a lot faster. So just something I wanted to encourage y'all to do from the get-go. Then you run, I'm doing a run. I want to make a new directory also under the root called model. And then I want to copy my fave icon over to source and my web app code over to source. Now, this is an interesting command. I hope it won't confuse you. Remember, our application's running on port 8501. And so I want to expose it to 8501 in my host system. And then this is the way you run commands. This command would actually run inside the image, inside the container once we launch this image in a container. And it's just what we saw before, Streamlit, run, and the name of our Python code that's a Streamlit app. Did not convert all these. There we go. Now, I'm running from Linux, so I use sudo, and then it's a Docker command. I want you to know, you don't have to include image in this command. I'm practicing, because pretty soon Docker is going to require that you say image or container. So I'm getting used to that already. So it will work now. Docker image build, but again, we could have done sudo docker build. Now, what's this dot for? When I use that dot, it's assuming that I am in the directory where a Docker file exists, and it's called Docker file. And it's actually called Docker file with a capital D because I'm on a Linux system. Otherwise, you could use the Docker commands to say F and here's the location of the Docker file and its name. I prefer this shorthand. Then I'm going to name the image and give it a tag of some kind. It doesn't have to be a number, but I like to use numbers. So this is the name I chose. It's just Streamlit _app, PySL _app, and I'm using 1. And if you came back later and decide, well, that was good, but I'm going to run a new version that's different than this because you learned some things, you could leverage from this Docker file, and now you're going to use a different Docker file, but you're going to tag it to, or whatever, however you prefer to track your different Docker images. Now, after a lot of work, because I did hit some errors, I got it to working, and I decided I did not want to copy over the model, the stored model, to source, and I'm going to explain why here in a bit. Again, continuous integration, continuous deployment. That's why I did not want to copy this over. I'm going to handle that a different way. Well, we're going to break down the run command now. Here's the run command, and I've explained it in detail here, but I'm not going to talk through that from here. You can read that while I explain here. So sudo docker container. Again, I wouldn't have to use container right now. I could just do sudo docker run, but I'm getting used to the future. And I tell it ahead of time, I want you to expose port 8501 to 8501 from the container to the host, or on the host from the container. I always forget which way, but it's one of the two. And you usually use the same, but you don't have to. You just have to use the right one for what you define inside the container. And this -D, you notice it doesn't have anything after it. That just means detached mode. I don't want to have to keep a terminal open for this. Now, this is the really important one for what I was just talking about. I want, for the present working directory on my system, a system variable here. Well, I run this command and I make it a variable, and I put it in these quotes, and I say the model, because that's where I'm storing the model up here, right there. And I'm actually making a mounted connection between the host machine and the container running in Docker Engine. And so that's going to be in the model directory. So those are going to be the same. Whatever's in this model directory will appear also in the model directory under root in the container. And then -P means I want to publish the container's ports to the host. That's really important after we did this, and probably it doesn't matter where you put it, but it should have been more clear to put it right there. I will correct that. And then finally, well, what are we running? We're running this image that we built and that successfully built. So a lot to remember. That's why I'm going to share this with you. Well, the results, it serves. And now I am going to show this real time, even though I said different there. Okay, this is what all that looks like. If I scroll up here, this was my latest build. And again, if I built all of this from pure scratch, it would look a lot longer than this, but it already built successfully these steps of the image build. This is what it looks like. And so step 1, from that step 2. And again, these are intermediate containers it's using so that when you do rebuild the image, it doesn't have to do it from scratch. If it sees that there's nothing new above a certain step, it just uses those old images, leverages from those. And then, so this one can take not as long as that initial from, but it can take a long time, and it'll redo it if you've changed something above this. So with all those pip installs in their dependencies, you don't want to do that, even though it was only 2 items in the requirements.txt file. And then this is fast, this is fast. Oh, this was an old one. I'm not doing that anymore. I'm just using that. This was an old one, is all I'm saying. There was another one. And so later on, though, I finally got this one to work. Sudo docker, the one I just showed you. And this is it, serving from the container. This is running from Docker Engine. And so I had already uploaded the file. I had run the model, and I download the output file. And we're gonna do that from scratch so that you guys can see it. So I was wrong earlier. The download output file button is dependent. So I'm just gonna browse to the file. I'm gonna open where I know it's at. So I put it, I saved it so it wouldn't keep going away. Because I actually, after it's used this file, I delete it so it doesn't dirty up my server, because this is a web app. People are going to have this on their local machine. Okay, so it's there, and now you can see that make predictions is available, but model output file, download the model, the output file is not. So I'm going to make the predictions, boom, does all those very fast, and then I download the output file, and I can get, oh, that's funny. I deleted an old output file, but I'm gonna force it to do this so we don't get confused. And those are gonna be this, just trust me, for time's sake, these are all the same. But that's how simple it was. And this is running from Docker Engine. Now, okay, big deal, Thom. Well, now I could go to AWS and create a virtual machine, or I prefer DigitalOcean. I could go there. By the way, I also love, my favorite two are DigitalOcean and Google Cloud Platform. I love those the most. Certain things I love more about DigitalOcean, certain things I love more about Google Cloud, but I much prefer them over AWS, and I certainly prefer them over Azure. I'm not trying to badmouth Azure. Azure's probably the king on security, and that's why it's really popular with the government and the Department of Energy, the Department of Transportation, the Department of Defense. Very unlike Flint with those groups. And I think it's because they use an insane amount of security. But I could go put this in a virtual machine on DigitalOcean and serve it up just the same. But then, Thom, why with Docker if it's in a virtual machine in the cloud? Good point. Don't necessarily need that, but the advantage is that I can then take that Docker image and readily use it without having to reset up everything on every virtual machine that I might put it on again. So it's super secure for a long time. Now that was a breakneck pace. What is some remaining work here? Well, what if we'd like to automate the model file updating okay, here's what I mean with that. Now, because it's pulling the model from here, I can update this. And what I did for the web app code here, let me show you this. It doesn't take very long to upload that model file. So I said, let me find where I did that. I hope I did it in the right place. Yes. So instead of, I had this model file name and with, I was loading the model, the stored model instance. I was loading it up here, if you remember. Now I say, no, I want you to do it at this level. And then that, well, shoot, I should probably even put this. I'm going to just do it right now while we're talking. If I put this here, if input file, I'm going to run the model. I'm going to wait to load the model right then. Why? Because if I've changed the model file, it's still this name, but if I've updated, it's just going to reload it each time. It doesn't take long, and that way I can easily update production this way. And it waits till I'm running it to do it. I could put it where you want it, but where it makes sense. Well, again, it's right here. So it's going to load that every time. But wait, what if this is up on a cloud service? And I'm actually controlling this in a repository somewhere, like on GitHub or DAG's Hub. Well, I can set up Jenkins at that point. And that's what I'm getting at here. We can use Jenkins, like I showed in the last presentation, for similar stuff, but with REST APIs. And we can, that way you trigger Jenkins in your virtual machine in the cloud to say, hey, I'm going to be watching this repository over here on DAG's Hub. And when that particular file gets changed, I'm going to copy it over automatically to this directory. And that way it's automated. And we, as data scientists, machine learning engineers, AI people, we want to automate as many things as possible. But what if we need more capacity? What if we have a model that a ton of people are using? And well, yeah, we might override the capabilities of that one virtual machine on one of those cloud platforms. And that's when we'd introduce Kubernetes. But I've run out of time, and I want to have time for questions. And I knew from rough experience that we couldn't get through another Jenkins demo and then get into Kubernetes too. It's just too much. So with that, I'm going to go back to the top of the file, and I can scroll around as needed, and I'll start taking questions if we still have time.
Hey, Thom. Hi.
Hey,
Thanks a lot for that pretty elaborate session.
Yes, thank you so much. I think the audience was so happy as well from the comments.
Good. I hope it was helpful. Again, treat it like this is what can be done. There's still be a lot of learning and review.
Yeah. I think on that sentiment only, there was a question that why do we even use FastAPI when we have Streamlit? I think we should take that first.
Oh, no, that is a great question. And I'm beginning to get a sense of why that would be. Let's say there's this one process. It could be a model prediction, like maybe you're creating an analytical tool, and it requires several different machine learning steps or several different analytical steps. But really that model is just delivering an answer. Well, it's much easier to just create a bunch of lean, fast APIs. Say, oh, here's some input, give me the output for that. We'll do that with an API, but for a bigger, like the end user needs to make a lot of choices, use Streamlit. Now, how can you bring them together? From your Streamlit app, you would be calling those little APIs rather than copy all of those each time and in different combinations into your model or your big analytical tool that you're going to serve with Streamlit. You can call those intermediate steps from the APIs that you need in this latest web user interface. And which ones are called may depend on what your users are choosing for options. So it's kind of like a dry principle. Don't repeat yourself. You can code a lot of little APIs and use them over and over again, just like you would use Python classes or Python functions that you're going to reuse many times. And what you're seeing too, here's the biggest motivation, guys. There are now some approaches where you can have one code base for web and mobile. And to make that really seamless, use a lot of APIs on the back end. I hope that one statement will motivate you to be good at both REST APIs and Streamlit or web UIs. And again, you could not, Streamlit team may make this happen. Right now, you can't use Streamlit to do web and mobile. But if you have an application, a big application you're developing, and you want it to run the same on the web and on smartphones, basically, like Android and iOS, you definitely want to use a lot of APIs. And they're very secure, too. When you use an API approach, and you're just serving it through those HTTP methods, like get, post, delete, and there's one update, I think. You really, those are light, fast, and you can bring them into any application. I hope that helped. That was a very important question, by the way.
On those lines, there is one point that one of our community members kind of mentioned.
Yeah.
Like FastAPI is to serve your functionality as a service, but Streamlit means to wrap it around an interface, a complete SaaS application.
Yeah. I think, Abhishek, that's a good way to look at it, but it can be even broader than that.
Yeah.
Yeah. There's one question that he has asked after posting this. Maybe we can pick that one. So he's asking, is there an easy way to implement user authentication with Streamlit dashboard? I deploy reports for my organization, but is there a way to secure them?
Yeah, they're actually, Streamlit actually makes this easy. A friend of mine at Echo and I were looking at this just yesterday. You can have multiple usernames with one shared password. You can have multiple usernames and passwords. And then you can even use, forgive me, Abhishek, I think it's SSO, I forget what it stands for, but you can even go deeper with stuff using Streamlit Cloud. Now, Streamlit's not trying to force you to use Streamlit Cloud and other database architectures that they've created for Streamlit. And I think they should make money. They've created an incredible tool, incredible convenience. But you see that I didn't use Streamlit Cloud here. I used Docker and it worked fine. So they're not trying to force you into anything. And the approach that my friend and I decided we were going to take is we're going to integrate Streamlit with a connection to SQL Server. We're going to store a username and passwords in a simple table in an existing database that way, and we're going to use that approach. And they make it super easy. If you just search Streamlit, username, password, you'll find all three approaches, and it's very elegant. Good question. We should just take Abhishek's questions. They're spot on. No, I'm joking. Thanks, Abhishek. Those are good questions and statements.
Maybe he has more he can put it. I think this was the last question from him.
Okay.
I think we have one more question, right? By Bella.
Yeah. Yes.
Yeah. I think it's the same question. Probably it's coming twice. Yeah. Okay.
Yeah. Okay. This is fun, Bella. By the way, I am not an anti-R person. I like to join into the jabbing sometimes about it. Like, you guys are pirates with the capital R and everything else lowercase and pirate. Antti Rask in Finland, he's my buddy, loves R. So does Al Bellamy. And of course, the famous David Langer, he's a big R guy. And a lot of people just think R is easier. My feeling is I kind of think it's what you started with and what you became intuitively comfortable with, but I'm not anti-R. And a lot of people on my team use R. And the first important FastAPI app we did, my manager said, Thom, can we pull an R model into Python and then run it in FastAPI? And I said, I'm sure we can, but let me go check. And I was able to do it in a day. And it uses a module called RPy2. That's literal RPY2. And so Dash is great, but from what I'm seeing, Streamlit's a bit easier because because it's Python based. And I wish we'd had time to show this. You can literally demonstrate data frames directly in a Streamlit served web app. In other words, you can use Streamlit like dashboards. So if you've already got a lot of time and energy and it's not hard to use Dash, keep doing it. But if you want to try it out and compare the simplicity and manageability of Streamlit compared to Dash, go for that. I can tell you one of the bigger teachers in LinkedIn in my community is Avery Smith. And I think he always uses Streamlit for dashboards, and he's a big fan of them. But no, I think just try it out and see what you think. You definitely, if you get good at the RPy2 module, you can definitely use Streamlit that way for R apps.
Yeah.
Okay. Thanks for answering that. I think we are done with questions. I don't have any questions. So please, do you have any question to put across?
No, I think it was great. Thank you so much, Thom. I know we took 20 minutes extra of your time, but thank you so much.
Seems like I always go over.
No,
real quick. So, Supreet and excuse me. Yeah, thank you. When I share the links for the DAGS Hub repos with them, they'll share them with you guys. There's some fine tuning I want to do to them. And I've done a different type of two-step directory structure process with the FastAPI session. That's why it's not up on DAGS Hub yet, because I still needed to do some refinement of that. But I took it to a much better place than when I presented. So I hope you guys find it worth the wait. And again, don't treat it as your sole source of learning FastAPI and Streamlit. Please invest in other learning sources too, especially their main websites, which are both very good for learning these amazing tools.
Thank you. Sure. Yeah. So once you share with us, I think Mudit kind of attaches it, right, with the video and all of that. So I'm going to do the same. Yeah.
So we'll add the DAGS Hub repo link itself so that people can access it. Yeah.
Excellent. Oh, thanks, Bella. I'm glad you liked it.
Okay.
I would just ask everyone that was here, if you're not already following me or connected with me on LinkedIn, please do that. And I try to share a lot of useful things, and there's more coming from integrated machine learning and AI in the years to come.
Yeah, maybe they should also know your work at Integrated.
Remember to watch the Rabbit Show.
That's good. We kind of did marketing for 4 communities in one forum. That's great.
Awesome. Thanks for all the good work y'all are doing at AI Planet, formerly DPhi.
Thanks to you, Thom, for being here. And it exists because of folks like you. So thanks a lot. Yeah, and to all the folks who are joining in, make sure you have a happy learning and happy weekend ahead. Cheers. We'll see you all soon. Bye.
Thank you.